CBT Nuggets JNCIA series, RIPv2 Deployment Lab. Well, now it's time to start to see everything we've learned so far in action in a real-world scenario. So what we'll do is we'll start out and I'll set the stage for this real-world implementation and what we're going to be doing. Then we'll look at our basic RIPv2 group settings, got some global settings and some specific neighbor settings. We'll build our RIPv2 export policy and we'll see it in action. And all along the way we'll look at different verification commands, different show commands to make sure that we've got our RIPv2 implementation configured properly. It's going to be exciting. You're going to like it. So let's check it out. Let's talk about our scenario. Well, the majority of topics we've covered so far in this JNCIA Nugget series have been really focused on you walking into your new job at Nugget Lab and then operating on an existing Juniper network with several routers using, for example, static routes. And later on in this Nugget series, we will learn more about operational monitoring and maintenance as well, some things that will help you when you walk into an existing network. But what I want to do now in our deployment lab here is look at a couple of examples of some things that we might want to do that involve RIPv2 dynamic routing and OSPF routing. So we're going to have to create a scenario here where you're going to have to actually implement the routing and the routers from scratch. So our first scenario is going to be this. You get into Nugget Lab, and within a few weeks they're going to tell you this. We have decided to go and purchase a company, okay? And this company that we're going to purchase is called Kiro Media. This is actually a company that I own myself. Kiro Media. So we're going to go purchase Kiro Media, but here's the deal. Kiro Media now is using RIPv2. As a matter of fact, they're using RIPv2 in their small network on Cisco routers. And so what we want to do is we want to find a way to go in there to transition from their Cisco routers to our Juniper routers using RIPv2. And then eventually we're going to take that network and go from RIPv2 and use OSPF, because we're going to be using OSPF here at the headquarters at Nugget Lab. Now that might sound like a kind of a strange esoteric scenario, but actually in the Juniper world it's much more common than you would think, because think about how ubiquitous Cisco networks are. And one of the biggest trends now are people just migrating or switching over from Cisco in their enterprise to Juniper routers and switches in their enterprise. So this is actually a very practical and real world example. So here's what we're going to do. Take a look at these two routers down here. Let's say that these two routers are the Cisco routers that are running now at Kiro Media. Okay? And these two routers, integrated services routers, are running RIPv2, and these are the networks. They've got a serial link between them, 10.10.10.0/24 network. They've got a couple of networks behind them as well. And we want to go in and take these existing RIP routers and eventually have the goal of replacing them with Juniper routers. But what do we have to do to make this possible? Well, the first thing we're going to do is this. We're going to take a couple of Juniper routers, a 2320 and a 2350. We're going to take these routers into the Kiro Media facility. And we're going to configure these two routers as RIPv2 neighbors, right? We'll take these two routers and then we'll connect each one of these routers to one of these Cisco routers, CR1 and CR2. And you can see what we're going to be doing here is we'll be connecting our new Juniper routers to our Cisco routers. It'll be on this network. Basically, it's a .1Q link, okay? So on gig E001.100 over on this 2320 and gig E001.200 on this 2350. And so once we have these two devices configured for RIPv2, we'll be ready to go ahead and connect these to our Cisco routers. And then once all the routers are speaking RIPv2, we can replace these Cisco routers with Juniper routers, or we could just remove them altogether once we get all the information converged, and we can take different steps from there. Now obviously going all the way to the end of this scenario is well beyond the scope of the JNCIA. We're actually getting up into the JNCIS area and beyond, this kind of migration. But what I do want you to learn, what we're going to look at here, is how when we bring in our Juniper routers into Kiro Media, how do we configure these to be RIP version 2 neighbors, and what are some of the steps we would take to prepare these particular interfaces here to ultimately connect over to these Cisco routers, and what are some policy that we can do to export information from our Juniper routers into our Cisco RIP version 2 routing group. Okay, so we're going to get to use some of that routing policy that we learned about in previous nuggets. Okay, so pretty exciting. Now, once we get through with that scenario, we'll say, okay, let's now move and say we want to go ahead and do an OSPF environment, and that'll be our second deployment lab scenario that we're going to do in this nugget. Sound good? Let's go ahead and take a look now at what we've got going on here. Okay, the first thing I want to do is I want to take a look at this existing router at Kiro Media, CR1, which is a integrated services router from Cisco, and I really want to focus on this link right here, okay, which will have an address of 172.20.100.10, because this is the link that's ultimately going to be connecting to this Juniper router when we do our migration. So let's go ahead and take a look at that particular router in my terminal session. Now, this is not a Cisco course, so we don't want to worry too much about the Cisco aspect of this, but I do want to show you, if I do a show run command on this router, I want you to notice something here. This is running the Cisco 12.4 code, which is fine, but I want to move down here and take a look at some of this configuration. You can see our interfaces. Now, this interface right here, this is the interface that is connecting, ultimately going to connect to my Juniper router. So what I'm doing is I'm giving it a sub-interface number of 100, and that's going to correspond to my 2320 router. In other words, it has unit 100. So we've got sub-interface 100 here, and our encapsulation is going to be .1Q, and it's on VLAN 100. And you can see my IP address here is 100.10 with a 24-bit mask. So this is the key interface I want to focus on, because this is the actual interface that's going to connect to my Juniper router. Now, there's other information here, like my serial interface and this 10.network and other interfaces. This will eventually be information that's going to be shared or sent over to my Juniper routers, because these are running RIP version 2. Okay, and you can see that right here, RIP version 2. And some other commands. We're going to be advertising the 10.network and 172, and we have this no auto summary because we don't want to automatically summarize on the classful boundaries, which is what Cisco does. So much for that. I just wanted you to see that this is the Cisco router that exists at Kiro Media, and ultimately we're going to be replacing this router with a Juniper router, a very real-world scenario. Okay, let's go over to our 2320 now, because that's really the router that we're going to focus on. Go ahead, we're in operational mode. We'll do a show configuration interfaces command, and that's a good one to do. Okay, so we can see, obviously, we've got, this is the interface that connects to our management VLAN, right? Here is that interface that's going to ultimately be connecting to the Cisco router, GigE001. So and I showed you this command earlier in this Nugget series. We're setting it up for VLAN tagging. It's going to be unit 100, and that corresponds to sub-interface 100 over on the Cisco router. And this is something that is very likely going to be in your future if you want these two devices to actually communicate with each other and share routing information. And we're going to give it a VLAN ID of 100. And this corresponds, of course, to our Cisco router, CR1, and then we're applying an IP address to unit 100, right? Not unit 0, unit 100. And the IP address is on the same subnetwork, right? 100, and this is .1. The Cisco router is at .2. Here we can see on GigE002, this is an important link, but this is the one that connects to the other router, okay? The other Juniper router, the 2350. Let me show you here. Take a look at our diagram here. This is the network between the two Juniper routers. So you can see that on GigE002, which is this interface right here on the 2320, this is going to be important because this is going to be the link that we're basically going to have the RIP group interface. So we'll be sharing RIP information, RIP version 2, between the two routers on this interface. Okay, so that is an important interface in this configuration. GigE003 is this link up here that goes up to either an upstream router or a service provider or whatever. It doesn't really matter. So this is the 2320. Now if I went over to the 2350, which is over here, I need to get out of this edit routing options area and get up to, let's clear this up, and we'll go do the same command, the show configuration interfaces command. Here we can see the same thing. Here's that interface that has VLAN tagging. So this is going to be ultimately connecting to the other Cisco router, which is CR2. This will be Unit 200 or VLAN 200, and that also corresponds to the configuration on that other Cisco Integrated Services router. Here's gig E002. This is important because it's on that 172.20.66 network, .2. This is what we're going to be sharing RIP version 2 information on between these routers. And again, we can see here, we're talking about this interface right here, .2 on this network, okay? Hit the space key. This is the one that goes up to that upstream router or service provider or whatever. And of course, here's our loopback address. And we had a loopback address configured as well on the other 2320. And these configurations should look pretty familiar to you. Okay, should look familiar to you because we configured these earlier on in this Nugget series. Now, earlier what we had done was we did static routing between the loopback addresses on these routers. But I removed that static routing configuration information so that we can actually implement our RIP routing. So let's go ahead and do that right now. Okay, the first thing I want to do is I want to get into the edit routing options area here. And if I do a show command, I should see, well, basically nothing. So what that tells me is I don't have any static routes set, for example. So this 2320, if I have an export policy, all I'm going to be exporting to that other 2350 over there and ultimately to those Cisco routers, all I want to be exporting are the direct routes. The stuff that we saw just a minute ago when I went and I looked at the show configuration interfaces on the 2320. That's all I would be exporting with RIP version 2. So what I want to do is I want to create a scenario here for a policy. So I'm going to actually what we call nail up a route. And this is going to be a route that is going to be just a simulation. Okay, it's going to represent some customer network or some partner net or something like that. And I'm going to use that route because I want to actually export it as part of my policy. Now, if I nail up the route of one of my existing connected direct networks, well, as we know, that has a preference of 1, right? Well, if I create a static route on one of those, the static route has a preference of 5. So I can export it, but it's going to be overridden because it's also a directly connected network. So I'm going to pretty much make up a network here that none of my interfaces are connected to, right? So in the edit routing options area, I'm going to set a static route. And we're going to say this is the 209.165.200/24 network. Now, what is the next hop? Well, there is no real next hop, right? This is a simulated customer or a simulated partner network. So I'm going to go ahead and say the next hop is discard, okay? So I'm going to be letting all of my other routers, my other RIP peers know that I'm the router to come to get to this network, but there really is no network. But this is a great way to set this up in your lab environment and to test out policy. You don't have to really have this connection. So I could also say, by the way, as a next hop, I could say reject, couldn't I? But the problem with, not re-elect, but reject. The problem with reject as a next hop is it's going to generate an ICMP destination unreachable error message. I don't really want that extra traffic going back to my other peers. So discard is basically just going to be a black hole, and that's fine for me. It's like going to the null zero interface on a Cisco router. So I'm going to go ahead and add that route. Now we want to remember this route because I'll actually be using this in my export policy for RIP coming up in a bit here. Let's go ahead and commit this. And now let's do a show command in this hierarchy, and we see there's our static and there's our route to 209.165.200, and of course it adds the .0 on there /24. So this is what we call nailing up a route, and again we can use this for a wide variety of purposes, and you'll be doing this kind of thing much more as you progress in your knowledge in Junos. Okay, we're ready to go ahead and configure RIP routing, and we're going to have to do it on the 2320 and go to the 2350 to, make these two peers work. So I need to get out of this area, okay? So I'm going to go top. That gets me to the top of the hierarchy. I want to edit protocols RIP. Okay, this is where we're going to go to configure this. And while I'm here, let me go ahead and go up and just clear this out. Now, we want to talk about kind of the different context that you can configure RIP, because you can configure RIP settings globally. You can also do them on a group basis. You can also do them on an interface or neighbor basis. Now, since I only have one neighbor here for right now, you would think that I only want to do this on like a neighbor level, and that's fine, we could do that. But usually, even if you only have one routing peer, you want to go ahead and put them into the same group or into a RIP group. And really, what a RIP group is, it means we're going to have the same export policy for all the routers in that group, which really pretty much defines those 4 routers that we've already seen on my diagram: J2320, J2350, CR1, and CR2 ultimately. Now, when I use the word neighbor, I really mean interface. Okay, so when we're going to configure a neighbor, we're really configuring an interface. So for example, I'm configuring my interface as a neighbor between the 2320 and the 2350 here in this particular nugget. And something else about the group, the RIP group is going to accept all of the multicast messages or broadcast messages if you're using RIP version 1. But if I were just to do, let's say, a set command right here under Edit Protocols RIP, what I'm going to see, set question mark, what I'm going to see are things that I can do globally. I can set the authentication key and the authentication type globally. For example, the type could be a simple password or MD5. The key is actually, a string of alphanumeric characters. I can set global hold down timers. I can globally choose how I want to send and receive RIP options. So let's go ahead and do that. Let's say set send and do a question mark here. I can send from this J2320, or really globally, and this needs to be consistent along all of the members of this group. For example, I can say I want to send broadcast messages, which is basically saying I want to do RIP version 2 and broadcast but be backward compatible with RIP version 1. So if I had peers that were RIP 1, that would be backward compatible. I'm going to go ahead and choose multicast. Okay, so we're going to say send multicast messages, and then we're going to set the receive type. And here we're going to say, do we want to do version 1 or version 2? We just want to do version 2. Okay, it's all about RIP version 2, and that's what those Cisco routers are running, as I showed you earlier as well. Okay, so there's 2 things you want to do right off the bat. What are we going to send? What are we going to receive? Now we could say we want to do some group options. We could say set group RIP and do a question mark here, and this is where we could see where we can do actual options as well. Like we could set the preference, so we could change the preference from the default RIP preference to something else for this group. For example, we've also got timeouts that we can do. We can do export policies and import policies on a group level. Okay, so these are all very powerful commands. I'm going to go back and do a couple of other global commands now. I've set the send method as multicast, and I've set the receive method as version 2. Let's go ahead and set up our authentication. Let's set the authentication type. Okay, there's a couple of options here. The type, and we've got pretty much either simple, which is a simple password, or MD5. MD5 is obviously going to be doing an HMAC, or a hashed message authentication code, which is going to provide integrity and authenticity between these RIP version 2 peers. I'm going to go ahead and just say I want to do simple authentication, and then I'll go ahead and set my authentication key, which is really the password, and I'll say it's going to be Nugget Lab. And this has to match, by the way, on all of my peers. So I'll need to do the same thing over on J2350. And by the way, if I want to merge with those Cisco routers, I need to set it up there. And I can do either basic authentication or MD5 on the Cisco routers as well. Okay, now the next thing I want to do is I actually want to deactivate something. And that sounds kind of funny, but let's take a look at our diagram real quick. Now earlier I showed you that we actually have a .1Q link between this Juniper router and CR1, and of course, obviously, fill in the blanks, we have a link over here between the 2350 and CR2. This is on VLAN 200, we're on VLAN 100 over here. What I want to do though, before I actually activate this RIP configuration and my export policy is I actually want to deactivate the RIP neighbor protocol on this gigabit 001.100 interface, because I don't want it to start sending information over here until I want to activate it. So I'll deactivate it. I get all my configuration done over here on my Juniper routers, and then I will activate this link and I would activate this link. And that's really how you would do it in the real world if you were merging this Cisco RIP network with this Juniper RIP network, right? So let me show you the deactivate command to deactivate this particular interface. Now I want to go up, I'm going to go exit, get up to the edit hierarchy, and I'm going to say deactivate, and we're going to deactivate protocols RIP, and it's group RIP, and it's the neighbor is gig E 001.100. Absolutely. And by the way, I'd have to do this command over on the 2350, and the command would be deactivate protocols RIP group RIP neighbor, and then it would be 200, okay, on that one. But it's 100 here. Now I want to go ahead and set up my neighbor relationship on this interface right here. Okay, so I'm going to go ahead and create my neighbor, which by the way is actually this interface gig E002.0. Let's go ahead and do that one. So we'll set protocols RIP group RIP neighbor. Notice we're setting this one, not deactivating it. And that's going to be gig E002.0. And by the way, we will use the activate command right before we're ready to merge these two networks together. Okay, so we're looking good. Okay, we're looking good. Let's go ahead and commit this. Now let's pop over to the 2350 and configure the 2350. Now before I do that, let me exit up to operational mode, and if I do a show, not IP, but show RIP neighbor command, I can see that the neighborship I have is basically the interface I just configured, right? Gig E002.0, state is up, the source IP address is the address assigned to that interface. The destination, of course, is the multicast address that RIP version 2 uses, 224.0.0.9. We're sending in multicast, and we're receiving version 2 only, and the metric, a metric of 1. So that's pretty interesting. If I do show RIP statistics, no statistics there, because my other peer, the 2350, well, that hasn't been brought up yet. It hasn't been configured yet. How about show protocols? Oh, can't do it there. Let's go to edit mode and do show protocol RIP. And we can see we're sending multicast, we're receiving version 2, and there's our neighbor, which is really our interface, okay? And if I even do a run show route protocol RIP, I've only got one route in there, okay? It's that actual multicast, 224.0.0.9/32. You can see it's RIP. There's our preference, 100. That's pretty much the only RIP route that we have. Now, once we get these two routers configured, we should see some different input or some different output when I run these commands. Let's go to the 2350 now. Now on the 2350, notice I'm in the edit routing options area of the hierarchy, but I want to get over to edit protocols RIP. So what I'm going to do is I'm going to go to the top of the hierarchy and then go to edit protocols RIP. That's a great way to get up to the top and get into the area you want to get into. Okay, so remember that. Top before the hierarchy you want to be in, it takes you to the top of the edit hierarchy and then moves you into that area. Let's go ahead and set up our 2350 now. We want to set the send as multicast. We want to set the receive as version 2. We want to set the authentication, set the authentication type as simple. We want to set the authentication key as Nugget Lab. We also want to get out of here and we want to deactivate that bottom interface, right, going to that other Cisco router CR2. So we're going to deactivate protocols RIP, group, RIP, and the neighbor in this case is GigE 001.200. That's the VLAN over there. And then we want to set the protocols for RIP, group, RIP. And then the neighbor was GigE 002.0, right? And we'll commit that. Now, we might think that we're going to just start sharing RIP version 2 information now, right? But that's not the case, and let me show you why. Remember, the export policy is by default in RIP to reject everything. So I have to explicitly configure my J2320 and ultimately the 2350 to go ahead and export not only the directly connected routes, but I also want to export with my policy that nailed up route that I made. Remember that 209.165? Because I want to apply a policy to it. So we need to go back to the 2320. That's where I'm going to set up my routing policy. Now, before I configure my policy, I want to do what a good programmer would do, and I want to set up like some pseudocode, right? So this is my 2320 RIP export policy. Okay, so I want to kind of write this out. This is a good idea to kind of, get in plain language what we want to do here. So I'm gonna have a couple of terms because I have a couple of different scenarios. So the first scenario, which is term 1, if, and this is the export policy, so we're talking about after information has been put into the routing table. I know that my routing table on 2320 has the direct routes and that one static route, correct? So I'm going to be exporting this to my peers. So the first thing I want to say is, look, if the route is from the protocol direct, and I know that I can do all different types of protocols, but in other words, if it's a direct connection, then if that's the case, then I want to go ahead and accept it, right? And if that happens, by the way, accept is a terminating action, right? So it'll just stop after term 1. But let's say that the route is not a direct route. Let's say that the second term is going to be if this route is, let's say, from the protocol static, right? And we know that I have one of those, 209.165.200/24, right? Well, if that's the case, we're going to invoke a route filter. And in this routing filter, we want to identify that particular route, right? 209.165.200/24. Now, it's not going to be everything that is this and longer, or longer than this prefix, or anything like that. It's basically going to be exact, right? So we want an exact match on this nailed up route. We're going to send this route in our export policy. So if it does match, then we want to change the metric to be, let's say, something like 3. Okay, so we're going to add a higher metric with that. And this is a great way for you to kind of force, if for example I was trying to get to this network, trying to force downstream routers to go along different paths. So this is how we control paths out of our network, right? We can say, if I push in my export policy and make this route have a higher metric, I can rig the game. Okay, it's more hop counts, right? So I can have another policy, export policy, over on my 2350, which is just going to use the default metric. So those down-level Cisco routers, they're actually going to go ahead and use that other 2350 router to get to this network, because I'm pushing it out from the 2320 with a escalated metric, 3 or 4, adding hop counts. All right? If that's the case, then we'll have an accept, and we know that that is a terminating action. Okay, so this is the pseudocode. This is the approach I want to take. So let's go ahead now and go into the 2320 and configure this policy. Okay, this is going to be so cool because, before, all we've really seen as far as policy goes is we've seen the actual configuration output with our containers and our semicolons and all those things. But now we're going to actually see the set commands that we use to create our policy. So we are going to set our policy options, and our policy statement is going to be for a policy. We'll call this RIP_EXP. It's our export policy, right? And our first term, or term 1. And by the way, the name of the term could be something besides 1. Okay, in an elaborate policy, the term name could be something much more intuitive than just term 1 and term 2. So term 1 is going to say pretty much if, or if this is from the routing table and its protocol of, and there's a lot of options here, right? All these different things can be coming from the actual routing table. So we're looking for basically if it's a currently directed route. That's what we want to say. So if it's from the routing protocol direct, I'll just use the up arrow because I have one more statement here. So it's still term 1. If it's from the protocol direct, then we want to accept it. Now, that is a terminating action. So if the route that comes from the routing table, this is the export policy, right? So this is post routing table. If it is a direct route, then we're going to go ahead and accept it. Okay, so as it's reading down through the routing table, it'll accept it. But if it's not a direct route, it might be something else. And we know that we have a static route that we might also want to have a policy to. So let's go ahead and do that. We're going to set policy options, but this is going to be term 2, our second term. And if this is from the protocol static, okay? So if it's a static route, and by the way, we could just stop here. And we could just say, if it's a static route, we'll go ahead and then accept it. So we'll accept all static routes as well. But we want to apply more of a policy to that. We only want a specific static route, right? Remember the route we nailed up, that imaginary partner network 209.165.200.0/24? Yes, that's the one we want to affect here. So we're going to say term 2 from, and then we say we want to apply a route filter, because it's not just any static route. It's going to be route filter 209.165.200.0/24. And by the way, it's not going to be prefix 24 or longer than 24, or between 24 and something else. It's not any of those match types. It's an exact match type. That's what we're looking for, right? Exactly that nailed up route. Okay, beautiful. We're not done yet with term 2. We want to go back and say, okay, in term 2, if it's a static route and it matches the route filter, then we want to do something. What do we want to do? We want to add a metric of 3 to it. Make it a hop count of 3. And again, we do this, like we talked about, to rig the game, okay? So for example, the 2350 over there could be also advertising this particular prefix, but it'll be at the default hop count. So the routers in the Cisco network would be using the 2350 router to get to this network. But if that route goes down, this one, which has the higher hop count, wasn't being used. It's got a higher cost. It wasn't being used, but now it's the only one available, so we can use that one. So we see we can use this metric in RIP version 2 to rig the game, and we can force traffic to be forwarded to different routers to get to different networks. That's what we do with policy, right? Then we'll say we have to do one more thing. We have to have a terminating action, accept, and then we'll go ahead and commit that. And let's go ahead and go up here to the top. Now we have one more big thing we have to do. We have to override the default RIP export policy. Okay, now we know the default RIP import policy is to accept all RIP routes into the routing table. Okay, all the direct routes, all the static routes, anything that's learned by other peers, for example. But the export, which is basically deny everything, we have to override that now by going to edit, and we want to say we want to set the protocols for the RIP group RIP, and our export policy is going to be RIP_EXP, and we'll commit that. That's the key command to get all this stuff rolling now. Now I'm going to wait a couple of minutes and give this thing time to cook. And now hopefully when we come back into the show RIP neighbor and show RIP statistics and show route protocol RIP, we're going to see more than just that one multicast entry. Okay, I waited about a minute, and now I've gone over to the 2350, because remember, the export policy is going from the 2320, and the neighbor is the 2350. So that's where I want to go to check out the results of this. So I'm going to say, let's do a show route protocol RIP. Oh, bingo! This is exactly what I wanted to see. This is awesome. Okay, now, so here's the original route entry that we had, which was the multicast route with the metric of 1. But now I'm learning from the 2320 about this network with the metric of 2. I'm learning about this particular network here, also has a metric of 2. And I'm learning about these, of course, via 172.20.66.1 on gig E002.0, right? But here's the one I really want you to focus on. Check out this route. Remember, this was the one I nailed up. This is that route that I created that goes to that simulated corporate network or vendor or partner network. And notice that it's still got a preference of 100 in its RIP, but look at the metric, okay? It added 3 to it. It has a metric of 4. So we can see that my route policy is actually working as planned. As it advertises or as it sends out this route and it exports it, now it's in the routing table in the 2350 with a metric of 4. So we get to see that policy in action. That's fantastic. Okay, what else could we do? Well, we could say, let's do a show RIP statistics. How about that? And we can see what's going on over here. Well, I've learned 5 routes, okay? Not much going on. I haven't sent anything because this is just basically being imported from the 2320. However, if I went over to that router, the 2320, and I did that command, show RIP statistics on the 2320, I should see, yeah, okay, check it out. 10 updates were sent, 9 within the last 5 minutes, 2 within the last minute. That's excellent. Now, while I'm here, let me show you something else that's pretty cool as well. I want to get into the edit area. I want to get to edit policy options and the policy statement for RIP_EXP, my export policy. I'm going to get into this context. I can come in here and I can do a show command. And what we're going to see is this is the policy as I taught you earlier, right? This is the actual configuration output, the hierarchy. And you can see, here's my term. This is the first container. So if or from protocol direct, then accept it. Term 2, from protocol static, and a route filter where it's exactly 209.165.209.0/24, then apply a metric of 3, accept. Beautiful. So this is actually the configuration output of all of those commands that I did earlier. And so this, by the way, is just an elegant, beautiful thing. We really get to see what we've done. And we've already seen the results of this policy over on the 2350. Awesome. So check this out. I want to show, and I'm going to pipe this to the display, and I'm going to display my set commands. So what we're seeing now is, in this same context of my RIP_EXP policy, we can see the commands that I configured right there. There they are. Set policy options, policy statement, and there's my RIP_X, there's my terms, there's my froms and my thens, there's the route filter. Fantastic. So really now I can say, let's go back up to the top here. What I could do now that I've got those 2 routers, and of course I want to go over to the 2350 and I want to configure my export policy there, and maybe on the 2350 I'm also going to advertise this same route, right? But maybe I'll give it a different metric. Maybe I'll only add 2 to that metric, so that would be the preferred path to this network from those Cisco routers. But remember, before those Cisco routers can participate, I would need to go in the edit configuration and I would have to activate the protocols. And I would have to say activate protocols RIP group RIP, and then I would have to say neighbor, and then the neighbor would be, of course, gig E001.100, right? I put that command in there. 001.100, and that would activate that command, and now that particular interface would start exporting all of this particular RIP_EXP policy over into the Cisco routers. Right on? Now, of course, on the exam, this is really kind of I've kind of given you, I would call this an intermediate routing, maybe even a little bit of advanced stuff here. This is, you will not have anything near this elaborate. Definitely no kind of configuration simulation question, okay? But you've seen the set commands, you've seen the results, you've seen me configure this, you've seen the actual policy in action over on the 2350. So you're really ready for the exam, and you're ready to go into this particular scenario at Nugget Lab and Kiro Media and beyond. Let me show you one more thing here. I've gone and made this elaborate RIP version 2 configuration on these two routers. Well, let's say you're in a lab environment and you want to basically say, okay, I want to wipe this out, and I want to go in and I want to start over from scratch and create an OSPF area, okay, and do OSPF, which is what we're going to do next. One thing I could do to make it real easy is use that rollback thing I showed you early on. So if I do a rollback question mark, I can go back to where, previously to where I began. So I could roll back to 5 and basically undo all of the RIP version 2 configuration here. So let's do that. Let's go down here. There's a lot of things. Do rollback 5 and then commit. And now if I do a show RIP statistics, haha, RIP version 2 instance is not running. There we go. So I've just kind of gotten right back to the drawing board here. So I'm ready for my OSPF. I'll go do that, of course, on my 2350. All right. Fantastic. I hope you enjoyed this nugget as much as I did making this nugget. I had such a great time. It's just such cool stuff. And hopefully everything's starting to really gel for you now. So in this RIP version 2 deployment lab, we set the stage, looked at several basic and even intermediate RIP group settings. We talked about a RIP version 2 export policy. We saw it in action. And then throughout the entire nugget, different verification commands. I hope this CBT nugget has been informative for you. I want to thank you for viewing. We'll see you in the next nugget, the OSPF deployment lab.